Okay, moving on. Let's go back to that ship movement script. We want to do something with this data. We're getting x and y. Let's do some work. What do you want to do with left and right on our ship? What are we trying to make here? Do you want it to side strafe left and right like Space Invaders, or do you want it to turn left and right like asteroids? Who wants to see rotate? Who wants to see translate? It's about equal. With a resounding vote of 2 and 2 out of a class of 39.5. I give myself 0.5. All right, we'll do. Let's do rotate. So we want to rotate. Where's the position, rotation, and scale of our game object? Where's that information stored? In what component? Transform. So we need to do some work on the transform. We need to, based off of what's happening with user input. So if well, okay, this dot transform dot rotate. Luckily, we have a function that'll rotate our ship. We actually have 6 different functions. One that takes Euler angles, one that takes an axis and an angle, one that takes Euler angles and a space relative to, one that takes individual floats, axis, angle, and space relative to. That one looks good. So we're going to assume our game is in the plane, kind of like a 2D action game, 2.5D. And so our ship's going to be like this. What are those 3? That transform. There's 4 pieces of information in a transform. What are those 4 pieces? It's position. If I do this thing, what are the other 3 pieces of information?
Right, forward.
The right, the forward, and the up. Okay, so to rotate, if we're talking about rotating based off of user input, we're basically saying to rotate about the y-axis. Because what that means is you're going to grab the y-axis and you're going to rotate the transform. So you can see naturally the forward vector is going to rotate to the left and to the right. If we rotate about y. If we rotate about x, we're going to see it tilt up and down. If we rotate about z, we're going to see it do this kind of thing. So we want to do this. So we're going to use y as our vector. We're going to rotate about vector 3 dot up, which is 0, 1, 0. That's the up vector. The angle will be axis dot, what value do we want to pass into this? So you're holding your gamepad. We want to turn the ship left and right. What on the analog stick are we doing with our thumb to turn left and right? This or this? Yeah, this. So axis dot x times, oh, I don't know, speed. Say rot speed. And there was a third parameter, which was space dot self. Okay. Oh, I added rot speed in there because I want to dial in the rotation speed, because it may not be fast enough just to rotate by -1 or 1. You know, I'll start it at 1 and we'll see how it looks. So there we go. Rot speed of 1. I'm going to push left on the analog stick. It's rotating, but it's doing something strange. What's it doing that's so strange? We actually want this to be world. The ship is rotating. But what are we seeing happening?
The origin's like way far down in this direction.
Right. So what we want to see is just that. So there's something else going on. Do you see the bug? Anybody see the bug? Yep.
You did world instead of self?
Didn't we do self before? Let's look at our ship. Same thing. What's going on? What we want to do is this, right? Anybody see it? You see the issue? Okay, let's put a pin in that for a sec. Let's do translate. If we want a side strafe, what do we want to do? There's a complementary function to rotate. This dot transform dot translate. Again, 6 functions. Which version do we want? One that takes a vector and a relative to, 3 individual floats, etc., etc. So it looks very similar. If we push left on the analog stick, which way do we want to translate? Right. If we push right, we want to translate positive x. So we want to, we'll need call this move speed. So we're going to translate by, and again, I think we talked about it last week. You can either do something in world coordinates or in local coordinates. So if we're going to translate by horizontally, we want to multiply move speed by the value out of our axis, which is what? Axis.x. Space dot self. Maybe this one will work. Okay, that's better. Although with move speed of 0, why is that working? Is there something else happening? That's faster. How can this be working if that's a 0? Is there some translate happening in the spawn logic script? Did we do that last week? Is that the bug? There is. That's the bug. Control KC to block comment. All right, that'll make our rotate work better. Stop debugging. Play it again. With a speed of 0, right? We expect not to be able to move. If we give it a 1, okay, we're translating again. That makes sense. If we rotate our ship 90 degrees, left and right is relative, so space.local makes sense. What if we want to translate forward and back, like a thruster or something? What would be the appropriate vector if we want to move forward when we press up on the vertical? vector 3 dot forward. Oops, space went back to 0. We'll put that back to 1 again. And there you go. So you got forward and back, you got left and right. So, okay, you got missile command. But let's try and get that rotate working again. So we'll comment out this left and right translate. We'll put our rotate back again. I think we want space.self for that, which is good. Last test. There you go. So rotating right. We're flying forward, rotate left. We're flying forward. That's not bad. And our missiles are firing in whatever direction we want the ship to face in. We should probably slide it forward a little bit, but we're on our way to getting a space shooter working. One last comment about move speed and rotation speed. These are hard-coded values, right? So the amount of distance the ship's going to actually translate and the amount of degrees it's going to actually rotate every frame depends on how often update gets called, right? Debug.log. If we want to know how much time has actually passed between the last time this function was called, we can use time.delta time. How many milliseconds has passed since last time we ran this function? Why is that important? Well, let's run it. We open up the console. It's under general. So it varies, right? It's about 0.016-ish milliseconds on my computer, right? So every that many milliseconds, we're going to add a multiple of the right vector. I have an i7 Asus laptop from last year. What do you think could happen if we ran our game? You know, let's say you save this, and then in 3 years you run this project again on a brand new laptop, an i14. Yeah. What's that? You're gonna have a higher frame rate, and your game's gonna run twice as fast. Have you ever tried to emulate an old DOS game or something in Windows? Why is this going so quickly? So it's because the code wasn't time-based. The code was tick-based. So every time the CPU did another cycle, we updated the state a little bit, which was okay back then. We didn't think of those things, but now we want to future-proof our games, and we also want to we want to lag-proof our games too. Have you ever played an online game and there's a really big explosion and you started to lose frames, or the game started to slow down until the explosion went away and then it went full speed again? What we want to do is drop frames so that we can have a constant frame rate. You still want your game to play at 30 frames a second. You don't want to feel like the interactivity is slower. You just want to render less often. And the way we do that is by multiplying by delta time. If everything is time-based, your game is time-proof. So let's do that. Instead of actually rotating by this amount, let's make sure we add in delta t into those things to time-proof our movement code. What do you think is going to happen if we do that and then we run our game again? It's going to work. It's going to work. It's going to be time-proof, but our values are wrong. Our values are in frames, not milliseconds. So raw speed should probably be, 50, and that should be 50, something like that. To at least get something comparable. It may not be exactly comparable. Hey, look, our ship can fly backwards. It's a cool alien ship. All right. Anyway. So keep that in mind when you're doing your movement logic, okay?